Proxima Centauri is the closest star to the Sun, located about 4.24 light years from Earth. It's part of the Alpha Centauri star system and is known to host at least two planets, Proxima Centauri b and Proxima Centauri c. Of these two, Proxima Centauri b is often referred to as a potentially habitable candidate. But how habitable is it really? In this video, we're going to break it down by looking at several key aspects to evaluate just how suitable this planet might be for life. First, let's talk about the habitable zone, which is one of the main factors in determining whether a planet can support life. Proxima Centauri b orbits within what's known as the habitable zone. This is the region where temperatures allow liquid water to exist on the surface. That's one of the most important requirements for life as we know it, since every form of life on Earth depends on liquid water. Based on its orbital distance of about 7 million kilometers from its host star, Proxima b receives roughly the same amount of stellar energy as Earth does from the Sun. Even though it orbits much closer to its star than Earth does to the Sun, Proxima Centauri is much dimmer, only about 0.17% of the Sun's luminosity. This means that despite its tight orbit, Proxima b still sits in the right temperature zone. So when it comes to the habitable zone aspect, we can give it a positive mark as one of the main indicators of Proxima b's potential habitability. Now let's move on to the activity of its host star, which is another critical factor in determining how livable a planet really is. As we mentioned earlier, Proxima Centauri b orbits at a distance of about 7 million kilometers from its star. Since Proxima Centauri is a red dwarf, that orbit happens to place the planet neatly in the habitable zone. But now the question is, what about the star's activity? Even though the planet sits at the right distance for liquid water, its close proximity comes with major drawbacks. Proxima Centauri is a red dwarf, which is the smallest and coolest type of main sequence star. While its temperature is relatively low, its magnetic activity is extremely high, much more intense than that of our Sun. On top of that, Proxima Centauri is known as a flare star, meaning it often erupts with sudden bursts of energy. These stellar flares release ultraviolet radiation, X-rays, and high-energy particles. One of the largest flares ever recorded happened in 2019, boosting Proxima Centauri's brightness in the UV spectrum by up to 14,000 times for several seconds. Flares like that can have serious consequences for any nearby planets, destroying ozone layers, ionizing important molecules, and even stripping away much of a planet's water supply. Over the long term, the high frequency of such flares could make it extremely difficult for life to develop or survive, especially without protection from a thick atmosphere or a strong magnetic field. So even though Proxima b sits in the right thermal zone, the extreme activity of its host star makes its environment highly hostile to life. The constant ultraviolet flares, X-rays, and strong stellar winds could strip away the atmosphere and break apart key biological molecules. Without strong protection from a dense atmosphere or powerful magnetic field, the planet would likely be far too harsh to support Earth-like life. That's why when it comes to stellar activity, we have to give Proxima b a poor rating in terms of habitability. Knowing how violent Proxima Centauri can be, the next thing we need to consider is whether Proxima b actually has an atmosphere and a magnetic field. Has research revealed anything about these two factors yet? The existence of a global magnetic field and a stable atmosphere is one of the most critical requirements for life. Unfortunately, we don't yet have direct evidence of either on Proxima b. If Proxima b has a molten iron core that spins fast enough, like Earth, then it could generate a dynamo effect that creates a global magnetic field. This magnetic shield would protect the atmosphere from stellar winds and cosmic radiation, reduce the bombardment of high-energy particles at the surface, and help preserve important molecules like water and ozone. On top of that, if the planet also has a thick atmosphere rich in greenhouse gases like CO2 or water vapor, it could trap heat, stabilize the climate, and distribute warmth around the planet. This would be especially important if Proxima b is tidally locked, with one side always facing the star, as it could prevent extreme evaporation and water loss. Combined, a strong magnetic field and a thick atmosphere could create conditions stable enough to support microbial life, at least on the planet's day side or twilight regions. But if neither of these conditions exists, then there would be no realistic scenario in which life could survive there. Since we don't yet know whether Proxima b has either an atmosphere or a magnetic field, this remains one of the biggest question marks in evaluating its potential. The possibility of life on Proxima Centauri b is an incredibly fascinating but complicated topic, because so much depends on factors we just don't know yet. Even though Proxima b is the closest exoplanet to Earth and lies within the habitable zone, the odds of it supporting life aren't particularly promising. With the data we have right now, scientists can't give a definite number. But some studies and simulations estimate that the biological potential of Proxima b is only about 5 to 10%. That percentage comes from optimistic scenarios, assuming Proxima b has an active magnetic field, a thick atmosphere rich in CO2, liquid water on its surface, and microbial extremophiles that can survive harsh conditions. But again, that's just speculation and based only on assumptions and modeling. Taking into account all the uncertainties in the research we have so far, we have to give its potential for life an average rating, neither completely hopeless nor highly promising. So even though Proxima Centauri b is often called a potentially habitable planet because of its position in the habitable zone and its relative closeness to Earth, the reality is far more complicated. Too many important unknowns remain, from the extreme activity of its host star to the unanswered question of whether it has a protective atmosphere or magnetic field. All of this puts its chances for life right on the razor's edge between possible and impossible. But that's the challenge of searching for new worlds beyond our solar system. Every new discovery raises even more questions, but also brings us one step closer to understanding our place in the universe. Will we one day prove that life can survive on alien worlds like Proxima Centauri b? Only time and science will give us that answer.